Yeah, we are recording now. This is meeting number 12 in this series of AI meetups of the scicloj group, AI Enclosure and elsewhere. And today we are 6 friends, and probably a couple more will join in a moment. And we will have a practice session, a study session about GRAY, this agentic workflows framework. And we have Cameron, the author, with us today, and a few other friends. Pierre and I are organizing the meeting. And yeah, we begin by, just introducing ourselves, saying who we are, what we care about nowadays. And then we'll just dive in to study. And yeah, um, Cameron, is it okay to begin with you if you wish to say something about who you are and so on?
Sure. Thanks, Daniel. My name's Cameron Barre. It's good to be back at another scicloj meetup. Generally, I care about closure, and then lately at work, we're building Grain, which is this framework for both event-sourced information systems and agentic workflows, and kind of mixing and combining the two for our customers and eventual products that our company will build. And it's all a big experiment, but it's a lot of fun. And yeah, that's me.
Yeah, thank you. And Cameron, by the way, gave a talk a few weeks ago and will be giving a talk in the upcoming conference in October. October 24, 25 will be this AI conference we're organizing. And yeah, if you wish to add anything more about that, then.
Only that I need to stop procrastinating filling out the abstract form.
Yeah, me too. Yeah. Hello, Mike. Would you like to say something?
Sure. Yeah. Hi, I'm Mike. I'm, longtime Clojure and Lisp developer. I work mostly in scientific and biomedical research applications. I'm also giving a talk at the upcoming conference, and I have to get my act on that. I've been doing. Let's see. I I've been looking at DISP, how do you pronounce it, and wanting to learn more about it. So I'm eager for the chance, but I haven't been busy with other stuff. I was just at a conference on protocols run by Venkatesh Rao. This was a not particularly technical thing, but my head is full of these. There's a group of people who want to kind of apply protocol thinking to the world's problems. So I've my head's kind of in that space. That now I'm trying to get back into more technical things. And the thing I'm working on, and I hope to give a talk at the conference, is using LLMs to support natural language query to complex graph databases. But I'm also interested in kind of H&E software architectures. Anyway, that's something about what's on my mind.
Yeah, thank you, thank you. Yeah, and by the way, Mike also gave a talk a few weeks ago, a little more in one of our meetups about, diverse projects in biomedical computing. And so the recording is public in our YouTube channel. And yeah, Pierre, hello, would you like to say something about yourself?
Yeah, so I'm glad to be there. My name is Pierre. I live in France. Actually, my background is music. So I was a guitarist, and I was very interested by jazz music and classical music and composing music, that kind of stuff. And at some point, I was tempted to try to generate some music using computer, and I came across this talk by Christopher Ford that was demonstrating overtone. And yeah, it made me try Clojure, and it was, I think, in 2013. And since then, I'm very passionate about about Lisp and all those kind of stuff. Yeah, and I'm work currently at Endor with Daniel and Alex. Yeah, and I'm very curious about what we will talk about today. I've done my little experiment on my side using Clojure, but never to a point where you are at with grain, I think. So I'm very curious about knowing more about this. Yes, that's it for me.
Yeah, thank you so much. Hello, Felipe. Would you like to say something?
Yeah, of course. My name's Felipe. I'm from Brazil, but I live in Sandy, Utah, in the US. I spent the past years working on fintech, and the past 6 months I've been working on health tech, building money movement operations for paying healthcare premiums here in the US. I'm a newbie with Clojure. Just started my journey about a few weeks ago, and it's been great. The community has been super helpful. I've been able to understand and I was able to put together like a small REST API using Datomic, which was super cool. So still baby steps and starting my learning with Clojure.
Welcome.
Thank you.
Yeah,
welcome.
great to meet. Thank you. Hello, Alex. Would you like to say something?
Hey, nice to be here. I'm Alex. Been working with Clojure for about 10 years or so. Currently working with Pierre and Daniel. We're working on a wellness app, and in particular, at the moment, we're coming to an aspect of the project where we're using LLMs, kind of in just a basic way at the moment. But we don't really have any sort of agentic workflows, and I haven't really delved into that area. So keen to learn a bit more. But yeah, quite excited about the possibilities. So I haven't really looked into grain apart from hearing from Daniel a little bit about it. So keen to learn a bit more.
Yeah, thank you. Thanks so much. I'm Danielle. I usually do statistics with Clojure. And yeah, recently I was inspired by Alex, seeing how nice it can be to compose systems with LLMs, how nice it can be to make it easy to make things. And I think Alex has inspired a few of us with a few things. And then we hoped think about how we can express more complicated situations. And we were curious about this idea of behavior trees with brain and declarative descriptions of workflows. And so that's one curiosity for us. Yeah, today I had one of these days where nothing works. So it means I'll be the most confused person in the room. So I'm proposing I'll share the screen because that's the mindset we want, just being confused together. And then maybe at some point somebody will tell me they wish to share the screen, and then we'll switch. Or maybe I'll just keep going and you all will be guiding me with, this little experiment. So we will dive in a moment. I shared the link to those Chris Ford talks about music in the chat. And just a reminder, we are recording. Are we? Yeah, we are recording. And after the call, we just decide, should we throw everything away or just share it internally in the community chat? Or maybe make it public. So if anybody thinks we shouldn't make it public, you just tell me and we don't. Or if you think we should remove something or stop recording, you just tell me and I stop, right? So it's this kind of meeting where we get confused. Right. So, right. So I think it makes sense to start from scratch. I'll clone the demo repo of Grain and we just practice, everything from scratch, including the installation and so on. And maybe Cameron, would you like to say just a few sentences about what Grain is, even though you gave a whole talk about it, just for computers? Yeah.
Sure, yeah. At our company, we build systems using a design methodology called event modeling, and we actually implement our event models using event sourcing. And so first and foremost, Grain is actually meant to be a framework for building event sourced products. And then as we sort of waded further into sort of our AI consultancy, through the use of some existing agent frameworks and whatnot by our Python developers, we decided to roll our own and to make it a first-class citizen in our event sourced kind of domain environment. That's pretty much what it is. And to learn the most, you would really like start at like what is event modeling and kind of learn about that, because that explains sort of like how a lot of the components in Grain kind of fit together to, it's kind of an ecosystem of loosely coupled components that work together to achieve making it easy to build event sourced information systems with AI. Hopefully is that enough sentences?
That's great. Enough sentences. Yeah. Pierre, maybe you have something to add about our intention for this meeting, or about anything, or anybody?
Yeah, there's for me, as I understand, there's two kind of big parts, the event sourcing part and the LLM part. So myself, I am pretty curious about the event sourcing part because I'm not familiar with it. And yeah, so I'm curious about this, but I don't know about you guys, what you want to focus.
Yeah, we will see in a moment. Yeah, great. So I think I'll share the screen and we will just start from scratch and see how it goes. So, yeah. I think you see my screen now.
Yes.
And here we have this GitHub org of our friends at OpenAI. We have the Grain repo and the macro expand 2 demo, which is a demo that Cameron gave in a previous meetup. And we will clone this and just start. Right. So I'll just move the Zoom controls. Right. So yeah, it's clone. Right, so we have it cloned. And now this project is a Clojure and Python project, right? That's part of the point, that DSPY is one of those Python packages that we cannot ignore, right? Because it does a few things that are difficult to do from scratch. And Grain allows us to connect to that, and we will need to make a few Python installations to this Clojure project. So you see we have this python.eden file, which is the way for Clojure Python interop to know where we have a Python environment. So we will use UV, which was the recommendation. UV is this Python package manager, right? And so UVN, I think, will create a virtual environment. And now we can actually, let us activate it for a moment just so that, actually, yeah, let us install a few things with UV. So I think UV pip install -r requirements, this file of few Python packages which are required, right? So this should work. And I'm just following whatever worked earlier today, and Pierre was saving me with my troubles. So with my trouble today, great. So we have it here. So we can, if we wish, do this activate thing just so that we can kind of experience having Python and all these packages. So now we are inside the environment. We don't need it for the Clojure workflow because the Clojure workflow has this Eden file that tells it where to look. But here we will just practice, running Python. So we have Python and we are in the environment. So now we can import the DSPY package. Right? And maybe we'll just try something with it, right? So I think we can search for DSPY. Like that, and right. So we'll not even see what the real magic of DSPY is, but just verify that it works for us. So here I'll just create a language model object, just so that we see that we can use them, right? And it assumes that we have this key in this environment, and I do have it in my environment, in my shell. And now we can use the model, right? We can say so it should work, I think, right? And just checking. So in this case, we're using OpenAI, and takes a moment, right? Oh, interesting. Great. That's great. Okay, so it did ask me to install another thing, Light LLM proxy. I don't even know why, but I'll do it. Maybe that's not so interesting. Why? Unless somebody has a comment about fast API. Why?
I have seen that. I'll need to add that to the requirements file. The funny thing is that it doesn't stop it from working. It's just it's just like an additional error that I don't know what that's for either, but I'll need to add that so that doesn't happen.
Yeah, thank you. I think like that. Yeah, great. So we'll try Python again, and we'll try, right, because we need to import. And then we'll create a language model. So for now, it is just a wrapper. We're not even demonstrating what's so special about DSPY. Just verifying that things are working for us. Great, so it kind of works, right? Great, so we have this environment, and now we'll use it from Clojure. And we'll do it with Grain. So we're opening the editor, and I think with this project, with this project, it was kind of nice to have, maybe we don't need the browser anymore. It was kind of nice to have the REPL running in the terminal. So here, if we open the labs.eden file of the project, we see that we have this nREPL alias that allows us to run Clojure with nREPL, so we can connect to it. So we'll run this.
Yeah, and the reason for that is that the demo uses a Python library called Textual that lets you build terminal user interfaces, and it has to take over the terminal. And so when you just start like with like I know you're not using Calva, but like in VS Code, if you use like Calva Jacken or whatever, the library has trouble taking over the terminal. But when you start it with the alias from the terminal, it works fine.
Yeah, yes, thank you. Yes, yeah, great. Yes, exactly. Right, so this is this hello world demo. And so now we will connect to the REPL. So I think, this is something that everybody have in the Clojure environment, being able to connect to a REPL running in another process, right? So we have this REPL connected, and now we evaluate this namespace. We're not making sense of it yet, but in a moment we'll read a little bit of what we have here. For now, we just wish to try the demo. And so here in the comment block, there are a few definitions of the relevant context for the demo, which is just a very basic chat app. And then we run this text user interface that you mentioned, and it is running now. So now it's supposed to be running. What is happening behind the scenes is that we're using some API, right? So we're a bit jumping, but in another namespace in this project, we have this DSPI definition that assumes we have this open router API key in our environment. Does anybody wish to say what open router is?
Sure. Open router is just a middleman service for LLM models and stuff. It lets you kind of like set up some credit and then lets you choose any number of different models, and they kind of shuttle your request to the different model you choose. It's just one of many targets that DSPy supports. Like Daniel in his terminal, in just the Python we did, he was using OpenAI directly. You can also use OpenAI or Gemini or Claude or whatever through OpenRouter. This is not like a recommendation to use it. It's just, it is what it is.
Yeah, thank you, thank you. Yeah, I didn't know anything about it, and Pierre just saved me an hour ago, and yeah, great. So we have it now, and that's the reason that things are working for us. By the way, hello, Timothy. Thanks for making it today. And yeah, so I just jumped to this internal DSPy definition that shows a typical use of libpython CLJ, the bridge from Clojure to Python, right? So here we are kind of requiring the Python module DSPy as a Clojure namespace, right? So a few moments ago, we were practicing things in Python, but now we'll be doing things similarly in Clojure. So maybe I'll just stop the UI for a moment so we can practice this. Can we exit? That's this. Do we have? No.
So are you on Mac or Windows, Daniel? Or Linux?
Oh,
You're on Linux.
yeah, Linux.
So for me, it's like the little, it's like Control P brings up like a command palette in that thing.
Oh.
So you could try that. There's a way to bring up a command palette, yeah, and then you can just type Q and hit enter, or yeah, navigate to quit.
Thank you. Yeah. Alex, you were gonna say something?
Yeah, I'm just trying to start this in VS Code. What was the trick that I have to do to get the kind of terminal UI working in do I jack in from VS Code or
No, you'll run Clojure. Try that in the chat. I put the message in the chat. You just you run Clojure with the nREPL alias, and that way it kind of sets up the nREPL kind of standalone so that the textual can take over.
Okay, fine.
And then we do Calva connect or some Calva connect something, right?
Yeah, like connect to a running REPL in your project or something.
Yeah, great. Yeah, great. So we just stopped the app when we learned how to, and now we're just looking into this little namespace, which is a typical Clojure Python interrupt example, right? So it is kind of equivalent to what we just did in Python. Oh, Alex, are you raising the hand? Yeah, you're saying something. Yeah. No?
No, I'm not.
Oh,
sorry.
yeah. Oh, sorry. Yeah. So we're just following exactly what we did in Python, and I think it is good to see how it looks in Clojure, right? So now we can just say no, right? And it should work, just making sure. Yeah. So that's the reason that things were working for us in the demo. And then on top of that, we have this structure with an event store and a behavior tree. And maybe for a moment, we can make sense of this little hello world demo, just to see that we understand everything about it. And then maybe we'll choose another one of the more elaborate demos, and maybe then we'll create something ourselves, or we will wonder about things and so on, right? So we're kind of following things that Cameron did in the previous talk, but we'll now get confused with the, internals and so on, right? So right, we see that we're having this def signature, and a signature is a DSPy concept, right? DSPy has this idea of signature, which is like, defining some kind of functionality that then is then compiled to some prompting, results in something which is not necessarily the text you're writing here. It may be a better prompt that DSPy creates for us by different ways that we can gradually improve, and that's part of the DSPy promise that allows us to, it supports us in this difficult task of making prompts. And, it kind of allows us to describe things in a way which is not necessarily the final prompt. Did I get it right?
Yes. At a baseline, DSPy helps with managing your structured inputs and outputs for you. In addition to, it does some really basic enhancements so that the model understands the prompt better. There's more advanced stuff too, like a demo that we're working towards having available for people is you can actually have this feedback loop where you figure out the prompt that works best for the first time, but then you enter into sort of a human feedback loop scenario where you can annotate the results of prompts in like an eval system or an observability system. And then DSPy can actually train and tweak the prompts over time and become effectively the manager of making those outcomes successful. So you no longer even have to like fiddle with the prompts. That's like way more advanced, but somewhere that we're headed and hoping to show people as well.
Oh, yeah, thank you. Yeah, yeah. And so for now, you just created a nice way to, prescribe this signature from Clojure. And later we may see an example with Mali schemas, which is maybe more sophisticated. But for now, we're just saying, declaring this intention that DSPY will use for prompting, right? And we are also describing the inputs and outputs, and it looks, reasonable, right? And actually, is this a Mali schema already? Yes, it is, right?
It is. It is. So
Yeah.
there's a little bit of magic here. So the leftmost keys, inputs and outputs, that's kind of a requirement of def signature. That's like sort of part of the DSPy signature concept. And then the inputs and outputs, the actual map, the left side of that, and we'll get into this a bit more, but it is related directly to the short-term memory in the agent, but we can skip over that idea for now. They also serve double duty in that the LLM is actually going to receive prompts with question and is expected to present output at the answer in this case. The right side of those keys are a subset of Mali. So those are already Mali schemas saying that question should be a string, and the descriptive text isn't just descriptive text. It actually ends up on a typed Python sort of class thing, and DSPy manages to shuttle that over to the model to tell it that question is the user's question and that answer is the response to the user. And those can be more complex declarations like maps and vectors of maps and things like that. And to a reasonable extent, they all get typed as they should, given the subset of Mali, given like the basic types like strings and int and double and all of that.
Yeah, fantastic. Thank you. Yeah. So right. And that is why you said you're using a subset of Mali, so you would be able to convert that to Python concepts, right?
Yeah, the most basic aspects of Mali, like not some of the more fancy stuff it does, but just basically so that we don't want to be in the business of inventing like new schema languages and stuff like that. And so we just said, hey, Mali's awesome. Let's use what we can from that, because obviously the basic Mali types are easily convertible to Python types basics.
Oh, thank you. Yeah. Alex?
Yeah, so we're using structured outputs at the moment for our LLM usage, but we're kind of working with sort of the raw JSON schema structured outputs, which seems to be quite a sort of small subset of what JSON schema can do. So it'd be great if what is the Clojure code that's going from a Mali schema to the sort of smaller subset schema of, and could we just use that for expressing
Yeah.
us in Clojure Mali rather than JSON?
You're kind of, the question is, could you just use well, so we just called the package that we made to do this CLJ-DSPy, and I think Daniel's looking at it right now, and maybe it's a bit of a mess, maybe it's not, but it does work. Theoretically, yeah, we could publish this through Grain, like through our Grain sort of like publishing repo, and you could just use this outside of any of the other sort of behavior tree or even any of that stuff. I think you could. We try to deliver everything as kind of like loosely coupled pieces. There are places where like there are some assumptions made, like the assumption made here is that you're using Mali, right? And the rest of Grain uses Mali for schemas. But I feel like this is one of the components that you could realistically take and use separately. Like you could even take the signature that gets generated in Python here using def signature and do just straight up dspy libpython clj interop and use that. And I don't know if there's an example of that anywhere anymore, but yeah, it can be totally taken out of the grain context. And if that's something that anyone is interested in, we could just we could add this to our sort of list of exports in our Polylith project.
Great, thank you.
Yeah, it is tempting to dive into this in a moment, right? Maybe
Daniel, there's actually maybe we'll look at this. I just wanted to point out there's a file that's I guess like a leftover file called blah.py in the macro expand repo, and it shows some of the generated Python. I think it's there by accident, but it does kind of show what happens. I think even for the case we were looking at, the basic case.
Well, just also one quick question, and I don't want to distract too much, but have you noticed issues when using structured outputs that the responses are slow because it's struggling to match the schema of the structured output?
I can't say we've noticed that. Like we've noticed that some models are slower than others. Like a lot of the times we like to use something like a Gemini Flash or whatever because it's fast, assuming it can actually do the job. But we don't really think about structured output that much. We just like define our CLJ DSPy signatures and just let DSPy take care of it. I can't say we've like explicitly become aware of like a bunch of latency caused by that or not.
Have you noticed it important when you're sort of like naming the fields in the schema? Does the LLM sort of get clues from the names of the fields in the schema as to where to put the things? Like it's important to semantically name the fields the right way to give it hints to help it.
Yeah, I think every time we interact with these models, we're sort of like declaring our intent for what we want them to do. And so to throw out, basically it's important to use semantic context and meaning everywhere you can because you're trying to steer it in the direction you want it to go in. And so, yeah, I would say like every field name is semantically important. It's important to add descriptive text. It's important to even reference those fields in the prompt sometimes, not all the time, but sometimes. And all of that combined, yeah, is meant to make it click or whatever you want to call it for the model so that it actually performs correctly.
Yeah, that's great. Yeah, and so now we see this generated file. And this was actually generated, is that right?
Yeah, that's here accidentally because I think I had like a print statement I was debugging at some point, but I noticed the file is still in the repo. And this Python, it can probably be like improved big time. I'm not like a Python expert. But basically what's happening is it's using the closure namespace that the signature was actually declared in to do some namespacing in the Python so that it's not polluting like the global sort of whatever you want to call it, where things live in Python. So it's doing some namespacing. And then you can see that the input and the output from the signature map is actually the chat inputs and the chat outputs here. And we can see that it's using, is it using Pydantic stuff here? Yeah, it's using Pydantic fields. It's got the descriptive text, and then that all gets kind of placed into a DSPy signature. So you have your inputs and outputs. And what DSPy does is it uses that like underlying Pydantic base model functionality to then provide or wrangle or marshal or whatever you want to call it the actual structured inputs and outputs that you want like to and from the model. And it even has some capabilities for models that don't even support structured output to kind of wrangle it using that descriptive model and schema to do what you want it to do anyway. It's pretty sweet. And it's like, of course, no, I don't think any of that is really rocket science because some people might ask, like, could you just build that in Clojure? And like, yeah, you could, but the end goal that we're targeting is this like feedback loop of prompt refinement, and so that's what we're really kind of headed towards with DSPy.
Yeah, fantastic. Yeah, and about this, about schemas and slowness, there was a blog post like a few months ago by our friend Pragyan, who described how they use closure instapass in situations where, other ways were slow. And Pragyan did give a talk about it, about, this curated way to handle, typed arguments or structured output in a way that was kind of more efficient. So maybe we can come back to that in another time, and practice those things. But I'm not up to date on this topic, so maybe, yeah, I don't know whether it's still relevant, but yeah. So right. So we're coming back to this demo, right? And we have this signature, which is a DSPy concept. And now we have a behavior tree. And so behavior trees, right? They are this concept of, a certain way to define a control flow, and we will try to interpret what we have here. And Pierre, maybe you have some comments about something? I'm wondering, or should we continue?
No, I don't have specific comment, but maybe if Cameron can say some, give some context about behavior trees and why are they appealing rather than other way to express.
Yes. Yeah, sure. So might help to understand like why even I was interested in them. Our Python programmers at the company were using this library called Hybrid AGI, and it's really reflective of a lot of the other agent framework libraries that are out there. They use like graph builder APIs, like setting up nodes and edges and things like that. And I found that to be confusing. Plus, you have to basically understand the whole sort of web of what's going on in order to make changes to them. And so I went looking for other kinds of control structures, and I found a paper, which maybe I can link afterwards in Slack or something. There's a paper and a book. It's a very small book, but they basically detail why behavior trees are good for sort of agentic applications, and that goes even beyond LLMs. It goes into robotics and game development, like game AI. And the reason that they're so good is that they're very reactive, in the sense that you can tick a behavior tree at some like periodic time interval, whether it's fast or slow, and the pieces and parts of the tree are able to react to changes in the environment, which is pretty neat. Another cool thing about them is that they're optimally modular, and that means that like any node in the tree can be a subtree, and subtrees can be put in, replaced, moved, swapped. And because they don't really communicate, the nodes don't really communicate with each other directly, they use a concept called a blackboard, which we kind of done a different twist on in our implementation, but it's basically like a key value store. It's like shared state between all of the nodes in the tree. They communicate through that, and so they can all observe what's happening, and what they do is connected to the internal state, not the structure of the tree. So you can change it very easily. Like that's the optimal modularity. Another cool thing about them is that they can generalize to like any control structure that has been invented, like since people started inventing control structures. So they can be generalized to like finite state machines, hierarchical finite state machines. There's a bunch of other ones that are covered in like the paper and the book that I mentioned. So they're basically like a Turing complete control structure. But what you get with them as well is like visually, if you were to take like a relatively complex finite state machine and compare it visually to a behavior tree, the finite state machine looks like spaghetti and it's hard to understand, but the behavior tree is a tree structure that is very simple and easy to follow as you go down the subtrees. And so it's, at the end of the day, it's just like a really nice declarative, reactive, very modular control structure, and that's why it's pretty cool. There's a Python library called Dendron, and was the subject of this paper. The guy that wrote this paper implemented Dendron and designed it, and it's like a Python behavior tree library for working with LLMs. Hopefully that's good. It's like it's not super complicated, but there are a bunch of details that are probably better explained by the paper in this little book. I think I can probably find the link right now.
Yeah, thanks. To me, the Wikipedia entry did help because it just explains those two main types of nodes in the tree very clearly. So we have these selectors, which are those nodes, branching further. And one kind is a fallback. And we see this term in your code, right? So fallback nodes are used to find and execute the first child that does not fail, right? So we are trying. Every time we fail, we keep trying those tasks till we have a task that does not fail. So that's a kind of fallback situation. So for example, we could try one way to get some computation or API response, and we may have a timeout because, it might be too much to ask for. And we get the timeout and we realize, okay, this is not working. We'll use a lightweight fallback, right? So we'll have this sequence of things by priorities, basically, right? And we'll use the first one which doesn't fail. So that kind of makes sense, this kind of node. And the other one is the opposite, right? Sequence nodes are used to find and execute the first child that has not yet succeeded, right? So it keeps going as long as it succeeds, which is just the opposite, right? And this is useful where we wish to, chain operations, right? Where we wish to have some sequential process, step after step. Is that right?
Yeah. One way to think about it, like to boil it down a little bit more, is that a sequence node always expects all of its children to return success, whereas a fallback node just requires one of its children to return success. And just those two alone can lead to some very sophisticated patterns, like Daniel was mentioning about like sort of trying one thing and trying the other. But you can also have like guard patterns. So at the top level of your tree, you might have a sequence of things you want to get to. And let's say like, let's just say it's like an agent that on the first run of it, like, because every node can return success, running, or failure. And if a node returns running, that bubbles all the way back up to the tree and says, hey, we're not done yet. And so it expects to be ticked again. And so there might be some state that you want to set up in the first run of the tree, like, have we understood the user's intention for what's going on here? We don't want to do that a second time when we come back around. And so you might guard that with a fallback pattern that says, have we understood the user's intention? If not, let's understand the user's intention. So one returns, the fallback fails because it's a condition and it's false, but the action to understand the user's intention succeeds. Then the rest of the tree plays out and some node returns running, and we come back around and we say, do we already understand the user's intention? Yes. So we don't do it again. We skip it and we move on to the next item in the sequence. And a great place to learn about that stuff is just the paper that I linked in the chat, because it really explains some of those patterns that you wouldn't, that are a little more sophisticated than what you might understand by just like glancing at the Wikipedia. There are some really interesting things you can do with sequence and fallbacks.
Yeah, thank you. I'm trying to find the chat.
Yeah,
Chat here. Oh, yeah, that's great. So that's the paper. Oh, like that.
the paper is pretty good for just because it's specifically about large language models. The book is more of like an in-depth cover. It's not a very long book, but it's more in-depth coverage of just why behavior trees are kind of popular now and where they came from, or why maybe they should be popular. But the paper focuses a lot more on like, this is how these are useful with LLMs and why it's better than like graphs or finite state machines or whatever.
Yeah, great. Is it true that in your, bigger example of the coding agent, you have a few of those cases of what you call a guard? Is that right?
Yeah, there probably is. There probably is in there.
Yeah, we may get there a little later today, or maybe not, maybe another time. Right. So yeah, great. So right. Great. So yeah, maybe we return to this hello world now. And right, and so we have a behavior tree and we have a sequence. In this behavior, just a sequence of tasks. And the tasks are of two kinds, conditions and actions. And because it is a sequence, we keep going as long as we get true, as long as we succeed, right? So first task says it checks. Sorry, here is the first task. It is a condition. So, it uses this predicate that checks for something, whether it is true or false. And it is looking into whether it has a certain context that it acts on, and this is the function that it uses, right? And this function will, look in the path defined here and check whether the short-term memory in this path has a value, as far as I understand. And so this is the function, short-term memory has value. This is the predicate that is used in the first step of the sequence. And we see that it's first, one of its arguments, the opts part, has those keys, path and schema, right? But we also see that it may have more, not just these opts, right? Because it may have more context that is kind of hidden by the framework, right? The framework allows us to write things more in a more kind of lightweight way. And so here, it actually doesn't care about the path and schema, so it seems. So I don't know whether.
Sorry, Daniel.
Yeah.
So there's two layers because all of our stuff is like kind of polylith architecture. So you were in the interface just now, and so the interface is just delegating. And I actually added some doc strings, but you probably don't have the latest. But I added some doc strings to the behavior tree interface. But you're looking at the interface, which just delegates to the core namespace, and so that one's probably just going to have like a doc string, and maybe it'll show you the keys that you might be interested in with the underscores and ignore them and just pass the context through. So if you're in the core namespace, you'll see how it's going.
Yeah, thank you. Now I looked inside. Thanks. Right. So, just coming back for clarity, this is this, user-facing interface. And internally, we have this function, right? So here we see that this predicate looks into the path and schema and checks whether in this path, in something called short-term memory, we have something that validates this schema, right? So in other words, what we check here, what we're checking here is whether in our short-term memory, which we haven't defined yet, right? In the question in our short-term memory, we have a string. That's what we're checking here, right? And yes, short-term memory is part of this system. It is this idea that we have this state that is mutable and changing and is, just representing the last snapshot of whatever we have been going on recently, in a way, right? So when the user asks a question, it will be in the short-term memory, and that is why it makes sense to ask, do we have a question in the short-term memory, which means, is it like the last thing we had or something like that? Am I getting it right?
Yeah, so there's and this is all like the ideas are in flux. Like so the system has short-term and long-term memory. And the idea behind that is that the short-term memory you don't even have to use long-term memory. The short-term memory is just a closure atom and it can be reset at your convenience. So like you can either have a tree that resets at every tick of the tree, or you could have a tree that sort of lives on, or short-term memory that lives from the life cycle of starting your tree and getting to a successful result or whatever, and it's finished. So it's just a closure atom. It's you can see here some of the little, like, there is connection magic going on between so if we go back to the declarative, but yeah, so you can see it's dereferencing there because short-term memory is just an atom that is in the context of the behavior tree. But if we go back to the data structure of the behavior tree, see we're saying like let's make sure question is there because our next operation is a dspy operation, and question, if you remember, I said, and when we define the signature, there's some magic. So we're defining the schema for question for dspy, but the dspy action node that we're about to get to actually expects question to be there. So that's why we're checking it, because it's assuming that question is going to be available in the short-term memory when we get to the next operation.
That's great. Yeah. Yeah. Oh, sorry, I'm not in the right place. So that is our tree. Here, the next thing will be an action. Actually, an action of action that calls the dspy function. And the dspy function will use this signature, which is a dspy concept. And this is the signature. And it just needs question in the input, right? So that is why we were checking this. That's great. So we checked we had a question. We call this dspy function with a certain signature, which means we will be making a call to the API, with, this structured input, output, and so on. And then we have another step, checking if we have an answer, right? And it might fail, right? And then we didn't even see the long-term memory here, but we understand that we're playing with the short-term memory, which is this stateful thing, and we may have the long-term memory, which is the history of everything, right? Or at least, the recent history of everything based on our event source. And last time we were looking into this, Pierre said to me, okay, what happens if we fail? What happens to our event log if we fail? And then we thought about it, and we thought it was an interesting question, right? Because it is not obvious to us what we want to happen. If we have this sequence of things happening, updating the long-term memory, possibly updating our event log, and then at some point, an API call fails or times out, then should we keep the history? Is it part of our history? Pierre, do you wish to say something about it?
I think you ask about it quite well. Actually, I was more curious about this notion of tick. What drives this tree ticking? But maybe we will come back to this later. But yeah, this idea of some of when to write to the long-term memory, at which stage of the process. It's not clear for me.
Okay.
Just looking. Yeah.
It might be more clear once we get to the conversational memory example, but so whenever we're talking about event sourcing, like the events are your domain. They're like all of the things in your business domain or your product domain that can happen. It's like the universe of things that can happen. So like if I sign up, then the user signed up. If I changed my email address, then the user changed their email address. And you would just apply that to whatever specific product context. And so depending on, like, say something fails, depending on, like, is there a domain event or is there something that you want to capture in your sort of universe of things that have happened in your product? Or is it more of like I just need to log that out to my logging system or something to, denote that there was a failure somewhere in with an API call? And so it really depends on like what you're trying to achieve and how you're thinking about like what you're using event sourcing for, because you don't have to use event sourcing at all to do some of these workflows, and or you can use it in different ways. Like the only way to write to your long-term memory as an agent is to emit an event into Grain's event store. So it really just depends, what are you trying to achieve, I'd say.
That's great. Yeah, thank you. Yeah, and maybe we'll see this in a moment. By the way, we are now 1 hour into this meeting. Usually we go for 90 minutes, and then some people stay longer and some people need to leave. And so I'm just mentioning that in case somebody thinks we should get to somewhere before this official 90 minutes time. And yeah, anyway, so this is a sequence, and that's the sequence we experienced where we played with this text UI earlier. Do we have more that we wish to explore about this hello world example? Right? We could, go here step by step and, define the event store, right? So
I just had a question about the chain of thought. What is that exactly? And apparently there's something also called tree of thought.
It's called what?
How that tree of thought.
Oh, interesting. So in DSPy supports a bunch of different sort of interactions that you can have. The simplest, or like the most basic one, is predict, and it's just like the LLM call that we all know and love, where you just make the call, you get a response back, you don't get any other information back. Hopefully you got back what you wanted. Chain of thought is where DSPy asks the model to explain why and how it arrived to the response that it gave you. Whether or not that's actually how the model works, like that's a huge question, but like it's still informative to see the model's reasoning chain. And so when you choose chain of thought, in the background, if you have the event store hooked up, our DSPy node with Grain will actually emit an event that the agent reasoned into the event store, so that you could go back and look and see for any given input and output why it arrived at that, or at least why it says it arrived at that. And I don't know about the other ones. We try to limit our footprint, so like we try to keep it. We're like, can we do everything with predict and chain of thought so as to make ourselves like sort of less coupled to other things like program of thought or tree of thought? I don't even know really what those are. So maybe they're good, maybe they're not. I don't know.
Cool, thank you. Yeah, it's pretty cool to see that it is integrated with the event store, that it publishes the event here.
Yep, and just on that point, like the event store is optional here, I think. So the nodes, they just check and see if you have the event store configured in the context for the behavior tree, then it will emit either predict or chain of thought. They both emit sort of an audit trail event. It's just that the chain of thought one has the reasoning attached, which is interesting because you can then feed the reasoning back into your workflow. And I think the naive coding agent like does that.
yeah, great. Yeah. Yeah, and maybe I think you mentioned it in the past, Cameron, that you support two different event stores. One here is in memory, but there is also a database one, a PostgreSQL one, right? And
yes.
somehow it is kind of almost transparent to us, whatever we use, right?
It's actually completely transparent. Yeah. So one of our goals in a lot of our system design for Grain is like we want certain components to be protocol driven, so that there is one unified way of writing and reading to and from the event store, for instance, and that switching to like a Postgres backend, for which we have an implementation for, is a one-line change at the very tip-top level of your configuration for your application. What that does for us in practice is, one, maybe you just want to write an agentic workflow, and so you can use the in-memory, you don't have to set up a whole database or whatever, it's very transient what you're doing. But for us, like we're working on like info systems and stuff for our clients, and so like it's very nice to be able to develop without having to like run Docker and stuff. And so I just use the in-memory event store a lot during development. but then when it comes time for production or like a staging environment, you just switch it to your Postgres configuration, and everything works the same in your code because it's protocol driven. It's just like a backend that's implementing the protocol. Another example is we're actually like, I don't know if this is illegal or not, but we extended the data log parser that I think Replicative puts out, and it's based on like the DataScript data log parser, but we extended that to allow for vector search, and so we added a vector. We're adding a vector store protocol, and we have an in-memory vector store protocol, or we have a protocol and an in-memory implementation. You query the vector store with data log, but we're also going to add like a PG vector and maybe an S3 vector store backend for that protocol. And so you will have one unified data log query interface for vector stores that might have different backends rather than having to change up your approach in your code just because you want to switch vector store backends. So that's just like another example of what Daniel was talking about, the kind of transparently switching backends for certain components.
Yeah, that is great. Yeah. Yeah, maybe just for a moment, we'll just, stare at this data structure. Yeah, so just so that we have some history here. And then we quit as you taught us to quit. And now we should be able to look into this event store.
Should be able to. Yeah, there we go.
Yeah. All right. So we have those events. Great. Great. So should we switch to another example, right? So we have a few of these here. Maybe number 3 is interesting because the 3 was kind of
No, number 3 is definitely more complicated. Like number 2 would demonstrate the long-term memory with less sort of baggage, the conceptual baggage. Because so number 1 is just conversational agent with no conversation history, and then number 2 uses the long-term memory to establish some conversational memory. Full disclosure, like I'm building some grain agents into a client project right now, and I haven't really used the long-term memory so far because I'm building the agents in the context of I'm already building read models from our event store, and so like I'm just like loading the read model into the short-term memory because it's already have the context I need, and so I'm still like on the fence about this sort of dichotomy between the short-term and the long-term memory, but it still could be useful, and it's in this example. And we may find cases where you don't have an agent that's embedded with other business workflows where you need to generate its read model, using this long-term memory stuff. I don't know. Hopefully that's not too confusing. Just saying, there's still open questions about the design.
Yeah. So let us look into the details, right? So here again, we have just a sequence, no fallbacks, right? Here we have 2 conditions before we begin, just making sure we have a question in the short term, which means the user just asked the question. And we have a conversation in the long term. When will this be false? I'm wondering.
Hopefully, it's really just saying like there might be a conversation because the first time you load it up, there won't really be one there. And it's saying if there is a conversation there, then it should match our conversation schema. So hopefully it'll never be false unless unless the data like structure for the conversation is wrong or something.
Yeah. Right. So if the user just asks a question, then we can continue with this sequence. And this is just for safety, and I understand, just making sure we have this conversation.
There's often some guard-like conditions that come before like an action or before or after an action.
Yeah. And then we
Did Daniel freeze? Is everyone else still there?
Yeah, I'm there. Um,
So we'll give Daniel a
Daniel,
moment.
we'll
sorry.
try to send him a message. Mm.
Cameron, I have a question. So,
Go
because
for
Dan
it.
is frozen right now. Um, so you imagine a situation where I have multiple users
Yeah.
using the same backend
Yeah.
in that code that Dan was showing. How would I be able to understand this different, like have the application understand these different users?
Yeah. So the way that so what we're not seeing is how we use Grain to actually build applications, because the agent framework is just one part of Grain. Like I said earlier, Grain is like a toolkit for building event source systems, and there's a whole like command, like a CQRS, like command and query side of things that exposes an API to like a client application or whatever. And so all of the here, let me actually look up the website for this. So when we went, the first version of our event store was kind of like handmade and whatever. The second version, there's some smart people in the event sourcing community that have come up with this idea of like dynamic consistency boundary. I just set the link in the chat. But our event store currently follows that spec. And so for every event that you put into the event store, you have the opportunity to tag the event with multiple tags of entity IDs that are relevant to that event. And so what you're not seeing in this agent sort of like demo is the fact that you can read events by specific tags. And so like, let's say that you have a whole conversation history and a whole bunch of other domain data for user A. Well, you can read user A's events in, and then all of the context for the LLM interaction or agentic workflow can be done in the context of only user A's events and some sort of domain constructs that you populate up into a read model from those events, right? That's how it would work. You just don't see that here because it's like totally divorced from the idea of an application.
That's super cool. Thank you.
And I think in the Grain, actually I don't know if there's like we're gonna do like a full end to end like with like a whole like user sign up and sign in and all of that kind of stuff. We're gonna do like a open source demo that's kind of bigger. But in the Grain repo, there's an example of service component, and that is like a little demonstration of reading and writing like events with tags and stuff. And I don't think there's users, but there's like counters that get created and incremented and decremented based on events, and that might be sort of illustrative of maybe what you're after. But there's no agents in the Grain repo demo, so it's eventually when we have some time, we're going to combine the two into something that's like a domain that's built with Grain and has agents in it. Are you looking for that component, Daniel?
Yeah, can I look for that?
Yeah, go into components, and then there's a Grain example service. Yeah, that's it. And I guess this is good because we just haven't even talked about it. But every Grain component, this is what I call a Grain service component. There's an interface, and if you go into interface or core, you'll see a similar layout of files. The most interesting thing in the interface is the schemas. So this is where we define like our domain schemas. Like we do event modeling to figure out what our domain looks like. And then we have commands, queries, read models, events, and we define all of our schemas here. And then if we go back up into the core namespace, so go up another level into core, we can go into our commands. And there's probably a command, yeah, like create counter. It's like the first item there. And so we can see on line 28 that we're constructing an event to store in the event store. It has a type, it has tags, so in this case it's the counter ID, and then it has a body which just restates the counter ID and the name of the counter. And so you can imagine if you have some domain data like users, and the users like, I don't know, it's like a music library or something, and they have a bunch of different albums they've added and things like that, and then you want to create like a conversational chatbot to interact with that. You would be querying on the query side of your application, or when populating the read model for the agentic workflow, you'd be querying by like the user ID using tags, and then that's how you segment into your actual like entities and stuff when you're working with the event store. I think there's queries too. Like we could see an example of a read if you go back a level and then into the queries file. I think there's a read in here. Actually, we need to go into back one. There's been some like changes in how I like to put things together. Go to the read models file, and then we'll see somewhere in here. Maybe if we scroll down somewhere, there's an event. There's a call. Yeah, there we go. So events on 47. Event store read. You provide the event store, and then you can provide a query. This one is just selecting by types, so it's not even selecting by like the counter itself. So yeah, we're gonna put together a more comprehensive demo that kind of puts everything together soon. But you can segment by types and tags, so entities that you want that are relevant to the events and specific events that sometimes you have like audit level events and things like that you don't want to have to iterate over in a linear fashion just to populate a read model, so you can selectively choose what types of events you want to bring into. I know all that's probably somewhat abstract.
Yeah, that's great. I'm glad we could dive into here. Should we stay here a little more? Any comments by anybody? Any questions?
Yeah, I could give a whole like hour-long talk on just this part of it.
For me, this is great. Like I've learned a ton already, so super grateful for this opportunity.
That's great. Yeah, we're really just trying to like share our ideas, but also like there's not like event sourcing isn't widely represented in the Clojure community, yet we think it's arguably like the most aggressively simple way to build stuff, because from an event sourced application, like you can't start with a relational database that represents like a mutable point in time snapshot of your system. That's what you work with. You can't take that and get all the way back to the things that actually happened, but you can go from the things that actually happened into a relational database for your entities, into a datomic database, wherever you want. Like you can always project the events into any of the sort of conventional software development paradigms that we see out in the world, but you can't necessarily go backwards into what actually happened. Most systems, even some use cases, even the way that some people use datomic, are throwing away some information as things change in the system. Like with datomic, even you might retain all of the changes to attributes over time, but if you're not also saying like semantically like this happened or that happened or whatever, like an event name or type, basically you're technically throwing away some information that is hard to retrieve without some kind of like inference process that isn't 100% accurate, versus always just saying this happened, this is what changed. You can always project that into some other representation. So we think that that's like a really, really actually simple in the like simple made easy terms. Like it's like the most decomposed and minimalist way you can start, and it allows you to defer like so many decisions for later. Now I'm just rambling about event sourcing. We're just trying to make that easier for people to get started with in the community, I would say.
Yeah, if you don't mind, I had a question about that. To be honest, I had a previous opportunity of implementing event sourcing at work on a Java code base. So essentially, we had like commands, right? And these commands would apply, side effects to the database or whatever system was connected to the system, and then it would generate an event like the database. I think the implementation, if I'm not wrong, had like some ORM that would eventually persist like an event to the data store. So how have you seen that? Like how have you implemented that? Like the event, the command, and the side effect, especially as it like relates to the side effect port.
Yes. So in Grain, we have a command processor component, which is like the canonical little machine that ultimately makes it to where you just have to provide a command handler, and it's just a function, and it gets called, and then the command handler can produce events. let's see. So the client is going to call into what we have called the command request handler, which is just like an HTTP layer adapter to the command processor. And then the command processor is our little machine that says, okay, I can find this command, I can execute this command. And then there's a data contract between the command handler and the command processor that says it allows you to return things back up through the command request handler back to the UI and stuff. And it also says, if you have any events, then I'll go ahead and store those in the event store. And so the command handler is a function that can read from the event store, get some read model that it can use to make decisions based off of. Yes, command processor or command handlers can and often are like side effecty. And so if there's like some external API that needs to be called or whatever, you do that interaction, you get some data back from that you can then store in the event that you're going to produce. And you can produce multiple events. It doesn't have to be just one, but so you can produce events. If you've captured anything from that side effecty operation, you can just store it in the event store. Then it becomes part of your read model for further decision making in the future or whatever. Currently, we just have reducing functions that go over the domain events and populate some like what you would normally consider like an object or read model. As latency becomes an issue, it's possible to do various caching strategies on that and do like incremental snapshotting and on that kind of stuff. And then if you want more query power, you can always project your read models out to something like a relational database like Postgres or whatever. Is that like along the lines of answering your question? Because we don't have like an ORM or anything like that.
Yeah, it is. And so, more specifically, the way I understood that, like that Grains implementation follows today, is that the events would be generated by the commands directly.
Yes. Yeah.
Cool.
So the command handlers don't actually store the events, but they do produce a map. And if the key like command result slash events is on that map, then the command processor is going to take that vector of one or more events, and the command processor hooks up to the event store component. It's a separate component, and it just says, hey, append these. And then the event store can do basically does schema validation. So all of the events have to have some schema or it'll complain. And so it makes sure that that's where like in the interface of the example service we looked at, there was a schemas file. All of those go into a registry that various parts of the Grain sort of ecosystem tap into to do validation at certain points. And so the command processor just says, hey, you had events, which is like a sort of, maybe the command processor wasn't pure, but it also doesn't modify the event store directly. And it just says, hey, you had events. I'm going to go ahead and ask the event store to append those. And then, yeah. Then there's like a whole pub sub mechanism that's hooked up. If you have a pub sub thing configured with the event store, it's like a protocol driven pub sub layer where like currently we just have like a in-memory one with core async, but you could hook up like Kafka or ActiveMQ or SQS and SNS, whatever you want. And then that would allow for like reactivity when things change.
That's cool. Yeah, that would be my next question. Yeah, the pub sub part.
Yeah, we're not really leaning heavily on that right now, but as we deliver different kinds of customer projects, we see ourselves implementing probably like I don't know if we'd go direct to Kafka, but just something to allow, multiple instances of our application to start reacting to events that are going on. But it's all there. It's all the protocols already built and built into the event store. So we have a concept that comes from event modeling called to-do processors. And the event modeling is all about making sure that engineers and non-engineers can stay on the same page when they're talking about product design. And so to-do processors are like an abstract concept for non-technical people that basically imply there's some background process that has a to-do list of tasks that emerge through commands being handled and emitting events and things like that and entities changing. And so in Grain, we have a component called to-do processor, which is a little machine that allows you to subscribe to events that you care about, and then those normally call into another command. And that's like, there's like a whole sort of reactive paradigm already set up in Grain to do that.
Cool. That's amazing.
Yeah, we are 6 minutes before the official time. Usually what we do is ask about whether anybody wishes to stay longer and chat about anything after the official time. And then, in any case, it is a moment to conclude. So if anybody wishes to say some concluding words, then it is a good time before some people will need to go. And then maybe somebody will stay longer afterwards.
I can stay longer for a bit.
That's great. Yeah.
Yeah, me too, a little bit.
Yeah.
Yeah.
Yeah. Yeah, there are a million questions to ask now.
Yeah. Do we want to take a look, like just before we end the official recording or whatever? We were looking at the conversational memory example, but we only looked at the behavior tree, and it might be useful to look right above it where the schemas and whatnot are actually defined.
Yeah, great.
Unless we don't have time. I mean, it just like a quick look because we didn't actually cover that part.
That's great. Yes. Yeah. So you see the screen now.
Yeah.
And yeah, great. So we are again in this conversational memory namespace.
Yes.
Here are the schemas. Oh, okay.
Yep. So the what we're seeing here is basically like the whole point of the long-term memory is basically it's just like AKA long-term memory, AKA your events and your domain. And agents actually come with their own domain. Like a chat agent is always going to have some idea of like I received a message, I sent a reply, and other kinds of agents. There's sort of like a whole like niche agent domain, and then you have your product domain, and then when you combine the two, you get this like composite of some crossover and overlap between the like less deterministic agent domain and your product domain. Here we're just seeing an agent domain, so we're defining event schemas that are going to go into our long-term memory or our event store. Message received, reply sent. There's a read model, and then we can see how so we define the event schemas, then we define agent schemas that is kind of like the language that the behavior tree is going to speak between the pieces and parts. Conversation is just a vector of this should look familiar to anyone who's interacted with LLMs, like a role and content, so user or assistant in the content. Then we have our question, our answer, and then when we actually go to configure the tree at the bottom, we're setting up the queries for the event store in the long-term memory, and the read model function that actually takes those message received and reply sent events and cobbles it up into the conversation history that the model is going to expect given the schema. That's actually the read model function there. Yeah, it basically just says like, given my initial state and some events, if I see agent message received, then I'm adding the role of user and the content into the conversation history, and if it's reply sent, then that was the assistant. And what that yields is just like that vector of maps that has the role in the content. And then if we look at how it's actually like all stitched together, like right below in the comment, we can see that when we go to build the behavior tree, we're providing the event store, the read model function that's going to take the result of the queries and actually produce like the model sort of decision read model. And then we have I think you can supply one or more queries that basically follow the protocol of the grain event store. And so we're just saying like, we just have one query and we're saying like, get all of the message received and reply sent. But if you were operating in like an application context, you might also be passing in a tag there, which might be the user ID of the user that you're interested in. And so when you supply those things, the agent starts to do incremental snapshotting of every time it runs the query as of the latest event it's seen, applies that to the conversation, in this case, the read model. And then that's what actually gets accessed from the short-term and long-term memory get merged whenever you go to do a DSPy interaction, and that's what actually the LLM gets to see the conversation that's been built incrementally from the long-term memory. Hopefully that's not too confusing. I was kind of rushing through that. and again, like it's jury's out for me on whether like I haven't had to use the actual long-term memory part of this because I access the long-term memory as part of some other command processing or query processing workflow. I already typically have a read model, and then I just initialize the short-term memory with that before I run the tree. So it's, you know, who knows whether that will stick around for the future, but maybe it will. That was all I had to say. Just to add that to the recording because the schemas and stuff.
Yeah, I'm glad it is recorded now. And yeah, should we stay a little longer? Any comments, any questions about this? I feel now that I wish to see more examples and I wish to practice that another time. And
Yes, me too.
yeah.
I am still curious about this tick mechanism. Could you tell us a bit more about it? It's not clear for me. When is there a clock that emits ticks?
Yeah, sure. I'll share my screen real quick if it's okay.
Yeah.
So can everybody read that?
Yes.
Okay, so tick is equivalent with saying run. In the behavior tree, like literature or whatever, when you run the tree one time, you're ticking the tree. And so let's say that you want to run the tree 10 times in 10 seconds. Well, you probably have some kind of periodic loop that's running every second. And you just run, 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 run. And what happens is the sort of signal propagates all the way through the tree. And eventually you either have like a failure that returns all the way up the tree, a success that returns all the way up to the tree, or running returns all the way up to the tree. And if you get running back, then you're probably going to keep ticking because you're waiting for the tree to settle on some successful or failed state. So there's nothing more complicated than that. And if we look at the TUI, the terminal user interface, this is what the behavior tree is being plugged into, like on the Python, the textual side. And so every time we receive a, let's see, every time we receive an input from the user, we're calling the handler that's been set up in this sort of like terminal app context. That puts us back into the closure right about here, this handle input function. We do a thing in the Python. We set up short-term memory. We're initializing it to something. We just put our question in the short-term memory because remember we have that first condition that checks that, and then we just say like, here's a budget, run it, for that budget. And if you get back, whenever it's not successful, we just run it again up to the budget, right? So, but if it's successful, and that one always is, it's like a one shot. So like this tree, there's no running here. All of these either are just going to succeed or fail. And so this budget is kind of pointless. But when you get to like the naive code agent, which doesn't work very well, but it works, but like don't expect anything fancy from it. This one goes into like a recurrent or like a reagent tool use subtree where it's trying to figure out what it needs to do next and if it has accomplished its goal. And so this one has a condition down here somewhere that basically interprets the results of having checked, given our reasoning chain, given the tool calls we've made, given the original request, are we done? And so it says if it sees that we're incomplete, then it returns running. And that's going to put us all the way back at the top of the tree so that the entire tree has an opportunity to be reactive if it needs to be. But more than likely, we just end back up in the tool use subtree and it runs through its little subtree again until it eventually says, we either failed because the thing has determined that what we're trying to do is impossible given the tools and the environment, or we succeeded. And so that's where you get into this concept of ticking more than once and needing like maybe a budget or something so that you don't tick indefinitely. Or maybe sometimes you want to tick indefinitely, but your reactive tree, you have a node that can check for user input that's saying, hey, stop what you're doing and bail out. That's where the reactivity comes in when you have more of there's like a spectrum of agency. There's like no agency, that's like the business logic we've all been writing, for years and years and years. There's a little bit of agency where you're doing some like LLM calls to maybe like summarize transcripts and things like that aren't completely deterministic. And then there's more like open-ended stuff like I would say like a code agent researcher kind of thing is kind of more on the open-ended side of things. And so that's where reactivity and multiple ticks and things like that and budgets come into play.
Thank you very much.
Hopefully that was, hopefully that answered your question.
very much.
And that's where other control structures fail to meet the requirements of reactivity. There are certain control structures that once they've started down a course of action, it doesn't really matter what changes in the environment. They just go and execute the thing that they think they already needed to execute. Like the robot keeps walking even though it's in front of a staircase or something. Whereas in a reactive control structure paradigm, the robot keeps walking, someone has picked it up and put it in front of a staircase, it is able to react out of taking that next step or whatever. So that's why the reactivity is interesting and important, is because when you're ticking it, it actually lets the whole tree, if it needs to, react to the environment. In our case, like in some of these agentic workflows, it might be we've set an agent off doing some task, but as the user, we're like, stop doing that or something. Not that this is only good for like chatbots. I actually don't like chatbots, but it's like it makes for a good hello world.
So dumb question. When it's reticking the tree and it's going through the tree again, what is it redoing?
It's just rerunning all of the nodes. Here, I have a visual reference so we can look at. Let me just share. Let me get there first. Yeah, it just runs the tree from top to bottom, and it runs the tree until it receives either like a failed, running, or a success.
But if some of the sort of leaves of the tree represent some running process, like some LLM query that we're waiting for a response from,
yeah,
the next time the tree ticks, it's obviously not rerunning all of those past LLM queries that it's run. So they're sort of
right.
Completed status with a response. It's not rerunning them, I'm assuming. But then if it's not what's the point in reticking? Because it's always going to just sort of pick off from where it left off, isn't it?
Sometimes that's what you want. So like, I'm looking for an example here of a guard pattern. This is the naive code agent thing. So this is a sequence, this is a fallback, and let's say we run through and we identify, like we say, have we identified the instruction that the user is actually, like, have we identified what we need to know to continue given what the user has asked for? And if we haven't, then we're going to build an action plan that might just be, I don't know what that's there for. So if we haven't, we'll build an action plan, and then we'll go through the list. We'll say, do we have sufficient context to answer this? Do we have, if we don't, do we need more context? We can ask for it. If we don't need more context, then we just need to decide if we need further clarification. And if we don't, then we end up down here in the sort of tool use and planning sort of area of things. So if we get to the end of here, so any of these can return running. That doesn't necessarily mean that there is an actual thing still happening. Like there are like async patterns that you can do with behavior trees, where if you return running, it actually does mean there's like an async, like a future or something running. But that's not that doesn't necessitate that. So like running might just mean our state goal that we're trying to achieve hasn't been achieved, and we need to re-enter and continue working. And so in this case, we might get to analyze objective result, and it might say, yeah, so we're trying to read the source of this file. We tried to open the file, but it's not in the directory we're in. We need to use like the tree command to check out the map of the file system. So that's going to mean that we have our reasoning chain and the tool call that we did, but we return running, and so we end up back up here. We're not going to re-figure out the user's instruction in the action plan again, because we have a guard here that says, so we've come through here. Do we already have the instruction? Yes, we do. So we just keep going. And we already actually figured all of this stuff out too, whether the context was sufficient, whether we needed further clarification. And so we're guarding, and we're just saying, we're using these as kind of like a predicate guard. So we're saying, yes, we already got that. We already got that. Yeah, so we end up back here. But we still have in our state the reasoning chain, the tool call results, the tools we called, the result of the last analysis. And so we come back through here and we are able to select a new tool and hopefully, do the file tree, we locate the file, then we read the file. And then we have enough to actually generate the analysis back to the user that says, yes, like in your file, that's like an implementation of a behavior tree or whatever. And so it's kind of like another way of thinking about loops. Like if you need to loop in a behavior tree paradigm, you're probably returning running, and you've built some subtree that is like reentrant in the sense that when you get back around to it, because you will just end up right back where you were, like you said, that you know what to do, how, and why you're there. And then you've guarded, like, yeah, if you made 10 LLM calls to set up this interaction, you don't want to make those calls again. You want to retain that information. And that all comes down to when you decide to reset your short-term memory, like you probably wouldn't want to reset it on every tick if you have stuff in there that you needed to know about on the next run through or whatever. You would basically retain certain aspects of your short-term memory through the lifetime until you got to like a finished or successful state. Is that helpful? Once you get the fallback guard thing, that's where you get your like, I'm re-entering, but I don't have to do things I already did kind of setup.
But I guess the idea is that sort of when it reruns, it's potentially got more context, so that some elements are rerunning with an updated context. Like it's worked out another tool that it can use. So when it's choosing the tools, it's now got something else available, so it can behave differently.
Yeah, exactly. Things can change in the shared state. So like the entire tree shares short-term and long-term memory. And any one of these nodes might have added a new event to the long-term memory. Any one of these nodes might have updated the short-term memory to include whether or not, we actually need further clarification or not. And so when you come back through, assuming you can't reset your long-term memory, that's event source. So you have that forever, you rebuild your read model. Your short-term memory, you decide when to reset that. So presuming you still have all of the state on the next run, you can pick up where you left off and have all that context. Now, in an application paradigm where you have like a stateless web server or whatever, that makes you think like, okay, what do I actually need to store in my long-term memory? Because my tree might return running. Like I have we're automating an advising workflow for a nonprofit that works with students that are coming out of high school. And there's like a specific workflow where given a student, there either is or isn't some next action that the advisor needs to take for them. And if there is a next action, we have to figure out which one it is. And so until you get to that last next action and do it, there is some next action required. And so we just have a tree that doesn't even use AI, that uses the fallback guard pattern to determine what action is next. And assuming you haven't met all the conditions, the tree returns running. And so the tree is running as in not finished executing totally, but we return back to the UI and say like, here's your next action. So you have to think across that boundary, the web request boundary at that point. If there's anything that you need to retain so that you have context for the next time you enter that interaction, it's probably a long-term memory thing. You're probably emitting events to your event store or your persistent data or whatever, so that you can call back up the context you need, given that a tree can be running across multiple like stateless sort of interactions, right? So like the examples that we showed today are contrived because there's no boundary there. So you can just have the same short-term memory and long-term memory. But in a more of a production like grade context, you probably are going to have more reliance on building your read models from your event store and stuff so that you can retain whatever context you need to. Hopefully that's helpful.
I'm tempted to ask something. Earlier, you said something about collaborating with people who are not engineers.
Yeah.
And it is kind of nice because another time you did tell us about the experiences of Clojure and Python people collaborating, and that was really, really insightful. So now is it okay to ask about how you work with people who are not engineers and how you model things together briefly, if you like?
Yeah, absolutely. Okay, so we use event modeling, which is like there's this guy Adam Dimitrick who was like a big domain-driven design guy for a while, and eventually, like him and some other people, they were like, DDD is excellent, but no one is going to read, especially a non-engineer, is going to read a 1,000-page book on how to effectively use like domain-driven design. And so what they did was they consolidated. Am I sharing my screen? Yeah.
Yes.
They consolidated like the whole idea of, they like distilled it into just how does information flow through a system. And so in a best case scenario here is like you have a graphic designer and they have like screens built out and stuff, but in the meantime, these white components are standing in for, in this case, a terminal application and just a background process. But it's basically how does information flow through the system? When do things change? What is stored when things change? And what sort of, we call them views or read models here. You know, whenever you need to serve a process or a screen, what does that view or read model or projection of the event store actually look like, and what role does it play? And then there's some business logic stuff. And so basically the blue boxes are commands, and that's a request to change the state of the system. It's packaged intent, so it's basically saying like, update email address or change, user first name. These are like your domain events. The events are, given that everything goes right with the command processor, the command's going to emit events. The events are like what you keep at the end of the day. So like if you turn the lights off at the data center and you turn it back on or whatever, that's what's still on disk. That's what you don't throw away. And then the views are just projections of events. So you might take all of the different events in your domain and you project them into what people would ordinarily think of as an object or like a relation, something that resembles like a relational set of entities or whatever. But in this paradigm, it's just that they're ephemeral. They're not like, we don't start from here and work from here. We start from here, save granular events, and we project these things. And so when we work with people who aren't engineers, the first thing we do is event storming, where we say, okay, given your world today or the world that you want to create, what are all of the things that can happen in this world? So like for our nonprofit customer, something that can happen in this world is that a student, submitted intake survey or something like that. And given that the intake survey was created, the system, automatically creates a student profile or something from that data. And so when we go to work with people who aren't engineers, we try to get them involved at this level first, rather than trying to cover all of these. Some of this gets a little more technical, even though it's really meant to be like where we're all speaking the same language. Like if you're a subject matter expert and I'm an engineer, we both know what we mean by ask question and question asked, because ostensibly you like know about the domain that we're like designing and building against. But we start here because you don't have to think about any of that. We just say, let's dream up like what recommendations generated. Like let's dream up like what happens in this workflow, and then maybe you start out and everything's kind of jumbled because you're inviting a whole group of people to collaborate and put different events on the board. And then we say like, okay, well, let's assemble that into an actual narrative that proceeds sort of in some order. And so we know that the student submits the intake survey and the system creates a profile, and then recommendations get generated based on the profile and the data sets that we have for the customer. And then maybe later on, like some operational person or the system, a student assigned to advisor or something like that. And then things proceed from there. So we try to get this sort of event storming done to generate these like plausible scenarios in the system that we're designing with non-technical people. This becomes our shared language. And then we take it and we say, okay, let's now model out all of the places where these are relevant. Where do things change? What screens and background processes are implicated? What do all the command schemas look like? And from that point on, this is like a really useful paradigm, because not only do we speak the same language with the customer or the client or whoever, but this actually starts to elucidate the actual surface area of the work, because you can chop things like any blue to a green is like 1 unit of work that would go in like linear or like Jira or something, or like a green to a white one is like a view serving a screen, and that becomes a task. And so like it allows us to stay on the same page with the customer as we design the product, and then also translate these into units of work and requirements that end up in our ticket system or whatever, that we go and actually have people go and perform those tasks. And then by the end of it, you have everything come together, plug in, and then you have like this working application. I could probably give a whole thing on event modeling too. Like I won't live without this. I started doing this or using it like 3 or 4 years ago, and I've only ever seen it be successful because everything becomes the same after a while, which is what we want. We want this kind of stuff to become boring, because there's only like 4 patterns that you can do with this, yet you can express like a system of any level of complexity. And it's like actually simple in like the Rich-Hickey sense of simple, because we're like properly sort of decomposing and atomizing the problem space and then gluing it back together on our terms. And then the benefit of the non-technical part is that you actually build what someone wants, because you were able to establish your shared understanding of the problem space with them through this event modeling process. So I'm sure there's like details I've left out or whatever, but hopefully that's, Daniel, that was helpful. This book is great. If you want to understand both event modeling and event sourcing, just get this book, because it's really good. Like, I didn't have this book when I first started learning about event sourcing. And if you just start learning about it on your own, there's a huge learning curve to event sourcing, because there's not a lot of, there are like many resources, but you can't really tell which ones are good. Some of them are like really way too enterprisey and like object oriented. There's other things that you just learn when you go to like build a system like this. But that book actually has a lot of those details that I found myself having to go and figure out on my own. And so event modeling and event sourcing, good book for that. You can also use event modeling with conventional relational database design systems. Like for the events, you just start talking about what table and columns are changing as commands get processed.
That helps a lot. Thank you. Yeah, we hoped it would be this kind of meeting where the expert can sit back and, we get confused and you can just rest, Cameron, but eventually, you got to teach us a lot. And some people may need to leave. It's getting late for some people. Does anybody wish to add anything, any thought, any concluding remarks before some people may need to leave?
I need to leave. This has been great. Thank you so much.
Thank you,
Thank
Felipe.
you.
See you next time.
It is great to meet you, Felipe. Yeah.
Yeah, thank you. Thank you so much, Cameron. I think we covered a fair amount of of material, and I will have to take some to digest and investigate some part of the whole picture, but it's very inspiring for us, and I already see how it will inspire us concretely in the work we are doing. So that's very valuable to me. So thank you.
Yeah, I'd love to learn more about that, just because we're trying to make something that's like super useful, especially for our own team, but anyone that wants to get inspired by the ideas or even use the stuff themselves, we're trying to make sure that it's really actually useful and beneficial and not just like taking up space on the internet. And so any kind of question, like there's a green channel in the Clojure Slack, you can join that if you ever have any questions. There's more of my team members there. And yeah, unfortunately, like there's like an iceberg of information here, and it's really hard to get past the tip of the iceberg on any given day with like a limited amount of time. But maybe if we all keep exploring it together, like we can dive down deeper towards the bottom of the iceberg. But I try not to info dump on people because it's way too easy to just like try to deliver the whole iceberg in one go.
Yeah, I agree.
Yeah. Any comment by Alex, maybe before we end?
No, just thank you very much. It's been quite inspiring. Certainly going to look up some of the stuff that you've shared.
Yeah.
Cool.
Thank you very much.
Of course.
Yeah,
Thanks
you
for your
see, in
interest.
my mind, it is like I in the last few weeks I was learning from Alex about the way to model a system, the way to architect things. So I still have this mindset, and now it is kind of fun to have something which is similar and a possible continuation. So we have something to think about.
Yeah, I think in our system, sort of some of these ideas we've sort of been reaching for with our sort of user log and thinking about things from more of an event-sourced perspective. And I think this gives us some sort of formality to how to start thinking about that in a more sort of established, proper manner.
Yeah, it's you can like if you ever go and take a look, or maybe I'll present one day, just the core bits and pieces that make the event sourcing side work. There's really not that much to it. You just want to have the pieces, and you need to know about the pieces to have the pieces. But like once you have them, it all becomes like the event modeling, where it's all just becomes commands, events, reactive processes, and there's like nothing more to it after that. You don't get into these like big architectural like debates. It's just like the answer to any problem is more events, and if it's a latency thing, it's probably like incremental snapshotting. But then the architecture of your actual code becomes so decomposed and isolated amongst all the areas and pieces that you don't have that like ball of mud kind of intersection thing that can happen organically. It's like a organizing principle that keeps everything separate and small and isolated. But you have to discover all that on the fly, and if you don't have the time or the opportunity, you probably won't, or you'll like shoot yourself in the foot somehow.
Yeah, we are under some kind of pressure currently, so we don't have all the time we'd like to have, but it's very good insights, and we will probably be able to inject some of those ideas, and probably at a later point when we will have some experience about them, maybe we will come back and talk about it to you, and we will be able to move deeper into the iceberg at this point. Yeah.
Yeah, totally. And if you guys ever just want to like chat offline somewhere or anything like that, even just about like fundamentals questions, anything, it doesn't have to be about grain. But if there's anything you think that our team could help you with conceptually, just let us know. Like we're always happy to chat.
Good. Thank you.
Yeah. Fantastic. Yeah, I suggest we'll now say goodbye to the recording, and unless there is any other comment for the recorded part, and we can say to our listeners, if that's published, then see you on the next times.